first thing we did in Unit 4 was we solved quadratics by the square root property and completing the square. Remember, with the quadratics, the directions might tell you which method you have to use. You've got to use that method. Others of them will just say solve by the method of your choice. If you're not sure what this looks like, go to the practice test. Practice test looks just like the real test, all directions and everything. And then we skip down, and it's still completing the square. In, here we go, 11.2, we use the quadratic formula. So make sure you know how to use the quadratic formula. Make sure you know the setup for all of these guys. 12.3 was all of our graphing. You will have to graph a quadratic by identifying its x-intercepts, y-intercepts, vertex. We usually listed vertex first. Vertex, x-intercept, y-intercept. And if you want, you can use your axis of symmetry to plot your other point. You should be familiar with the word problems from that section. Does anyone remember the key word in the word problems? What did we look for in the word problems? Let's see. Oh, we're too far. Word problems. If I can find them. Word problems. So there's different, you're going to have multiple types of word problems on here. So it's not just going to be, oh, I know when I see a word problem, I do this. Because we're doing word problems today. Everything we do today is a word problem. Different type. Max or minimum. On a quadratic, what's that point called? Vertex. So if you have a word problem that asks you for a maximum or minimum, you're looking for the vertex. That was the other important part of 11.3. 11.4, you did very well with, at least on your drills. Get this thing out. That was graphing, now I'm all off, graphing our exponentials and identifying domain and range. So make sure for both the, I'm still in quadratics, for both the exponentials and the quadratics that you can identify the domain and range of the graphs. Again, go to that practice test. Those problems are on there. So we did that for both quadratics and exponentials. That was our 12.1. 12.2 was all of our rewriting, going back and forth, and evaluating where you just put it equal to x. Rewrote and solved. 12.4, we had exponential equations. How did you know equation was exponential? What are we really looking for? Yeah, the x's in the exponent. Because some of these problems might just say solve. You gotta know what type of equation you're trying to solve so you know what method to line it up. For our exponentials, we looked for that same base. So we could cross it off. We solve logarithmic equations, which were the same as the previous section where you just rewrite and solve for x. Did a lot of stuff in Unit 4. Let's see. What was the last thing? 12.4 log equations. Guess that brings us to 7.8, which is our last section. This is solving variation equations, which I really like variation equations because they're all the same. They're all basically the same. Even if you get a really wordy word problem, just ignore most of the words and look for all the keywords. These are completely about keywords. There are keywords in all of these problems that will be present. So here's our key terms. And this is part of what the extra credit in 7.8 is. Whenever you see the word varies in your problem, you're going to put equals k. So there's going to be something that's varying, so it's going to be on the left side. Then you see the word varies, just put equal k, and then we're going to keep reading the problem for the rest of these words. K is what is called our constant of variation. And we always solve for this first. The first thing we do after we get our equation set up is we solve for k, our constant of variation. If you see that something is varying directly, we know it's multiplication. If something is varying inversely, we have division. And if something is varying jointly, It is again multiplication of two or more factors. So directly and jointly are essentially the same. Jointly just means there's going to be more variables, but they both mean multiplication. So what we're going to do is we're just going to read through these sentences, look for those words, and set them up. The other thing you might see, and I know one of these is in the classwork today, is the square of, and I put x in quotes because it could be any variable. But if you put the square of x, how do you think we might write the square of x? Square of x. X squared. Versus, I find sometimes that gets confused with the last one, which is the square root of n. So if it's the square root, then you put your radical in. But if it's the square of, it's whatever your variable is to the second power squared. And then, so how about the cube of y? Y, yeah, y to the third power, y cubed. Yeah. So they sound kind of funny, square of, cube of, but it just means that's the exponent. So to solve these variation equations, we're first going to translate into our mathematical equation. So we're going to write our equation and then solve for k. You'll have all of the information to fill in except for k. So the first thing you do is always solve for k. K is in every problem. It's a different number in every problem, but it's in every single one of these problems. Then we're going to rewrite our equation, but now we know the value for k because k doesn't change within a single problem. That's why it's a constant. So we've got to find the constant for that problem, and then we can answer any of the other questions. So then we're going to answer the question. So find k, write your equation, answer the question. So this is what one of these problems looks like. Y varies directly as x. Y equals 30 when x equals 6. Find y when x equals 10. Read these word by word. Don't try to read them all at once. So let's just go through. So y, okay? First thing, start with y. Varies. What did I say always goes in place of varies? Equals k. And now we've got to decide what's happening to k. Is it being multiplied or is it being divided? So our next word, we're literally going word by word. Our next word is directly. And directly means we're doing what operation? Multiplication, so times, and then as x. That's what we're multiplying by. So if you just go word by word, we can get our equation. So there's our general equation, y equals k times x. Now let's use our complete set of information. So this is our complete set. So y equals 30 when x equals 6. So I'm going to go into my equation. I'm going to replace y with 30. K I'll never know at this point. That's what we're always solving for first. So k times, and then x is 6. How do I solve this for k? Divide by 6. It's being multiplied by 6. The opposite of multiplying is dividing. So to solve for k, I'm going to divide both sides by 6. So I get k equals 5. That k is not going to change in this problem. I could ask you 10 questions now, and they would all have k equal to 5. So what you do after you find your k value is you go back and you replace it in your original. So y equals, in place of k, 5 times x. And that's going to allow me to answer any question from here on out. So y and x are variables, meaning they can change however many times I want them to, but k is a constant. K is never changing within this one problem. K will always be 5. So we write our equation, just go word by word. We solve for k. K is a constant, doesn't change, and now we can answer the question. So find y when x equals 10. So that's the question, this last part here, so that's my complete set. This is the question. So I'm going to go to my equation, and I'm just going to replace x with 10. So y equals 5 times 10, or y equals 50. And that was what, you don't need to put this last part, but it's when x equals 10. So after you get your equation, you've got your number in for k, you just take the question information and substitute that back in. So you substitute twice. You substitute to find k, you substitute to answer the question. So the answer to this whole question, y equals 50. That would be your final answer. So you notice, like on your homework, you have to do all the evens for 7.8. So I gave you all the even answers, and it's just a variable equals a number. It's the whole answer to these questions. So let's read through B, set it up, and solve it. So y varies. Start right there. We don't even need to read further. Y varies. So our variable, again, is y. And what goes in place of varies? Equals k. There's always a k after the equal sign. There's always a k after the equal sign in these variation problems. Next word, inversely. That's going to tell me my operation. Division. So this time, instead of multiplying k, we're dividing k. And as our next variable, x. Y equals 4 when x equals 12. So there's our complete set of information. And that complete set always lets us solve for k. So I'm going to put in 4 for y. K is still there, and 12 for x. What's k equal? 3/12 is 1/4, not 4. Let's think way back. So we think back to Unit 2. When we had equations that had fractions in them, how did we clear the fractions? Multiplied by what? Reciprocal? Yep. And for us, the way we said it was multiplied by the LCD. So to get rid of a 12 in the denominator, all I have to do is multiply by 12, which means multiply both sides by 12. So when you have these inverse problems, to solve for k, you're just going to multiply both sides by whatever the denominator is. So we get 48 is equal to k. And again, give yourself a little check. If you said 3, which is the common answer here, because you see the 12 and you see the 4, and you see, okay, 12 divided by 4 is 3. But if you put 3 back in for k, 3/12 is not 4. But yes, 48 divided by 12 is 4. So when you have one of these inverse problems to solve for k, just multiply by the denominator on both sides. That'll clear it out. Or multiply by the reciprocal. The reciprocal of 1/12 is 12. So what do I want to do with that 48? Where's that 48 going? Right where k was. So we're going to take our k. K is a constant. It doesn't change. So we're going to write our equation with 48 in place of k. X and y are variables, so they'll be forever changing, but k is constant for this problem. And then what's our question statement here? Find y when x equals 8. So I've got to look at my equation now, see which variable I have. So this is my question here. And just replace the x with 8. So my final answer after all that work is that y equals 6. So y equals 6 when x equals 8. We're just completing that set of information. Questions? All right, C, M varies. Stop right there and start writing your equation. So the variable I'm starting with this time, it's not y, it can change. So I'm starting with M. The only variable you will not see is k, because k is always going to be our constant. So M varies. What always comes after my equal sign? K. Always have a k. jointly. What operation am I going to be using? Multiplication. It just means there's going to be two or more factors there. So times, so notice as F and P. So it's going to be times F times P. That's what jointly just means there's more than one thing. And then we have our complete set. You have to have a complete set that will fill in every variable except for your constant. If you don't, you wouldn't be able to solve the problem. So somewhere you will have a complete set that has everything except K. So I'm going to go in and fill in my variables. So we know M is 110. K is what we'll always solve for first. F is 5 and P is 4. So I have 110 equals K times 5 times 4. So I'm going to multiply that 5 and 4 together. So 110 equals K times 20. And then to solve for K, what do I need to do? Divide by 20. If it's being multiplied, divide. If it's being divided, multiply. So I get K equals 5.5. Will not always be a whole number. And what am I going to do with this 5.5? Put it back in. Go back to the original, back to the first thing we wrote, and put that K in. So my equation to answer the question is M equals 5.5 times F times P. And now that we've got all of that worked out, notice we didn't even read the question at this point. We didn't need it yet. You don't need the question until the very end. So don't read the whole thing and try to put it all together all at one time. Just piece by piece. Write your equation, put in your information, now answer your question. So we want to find M when F equals 10 and P equals 3. So I'm going to go into my equation. I'm going to replace F with 10, and I'm going to replace P with 3. So M is going to be 5.5 times 10 times 3, which is 165. Questions? So it never gets harder than that. It's always the same process. But you can put more things in it. Like in D, there's more things. But that's about all we can do to make this harder. We'll also have the real word problems in a little bit. But if you read them like this, where you just cut out all the unnecessary words, they work exactly the same way. So for D, again, there's a lot of stuff there. I'm not even going to read the whole question. As soon as I see that this is a variation problem, I know I'm going to go word by word. Hang on. I did 5.5 times 30. Yeah. Oh, did you do 5 times 5? I can see. That's why I used the parentheses, but yeah, it's 5.5 was our K value. Try that. So there will be, two types of word problems now. There's the quadratic word problems, and there's these. So if you see maximum or minimum, find a vertex of a quadratic. Your function will be quadratic. For these that say varies, we know we're just going to go word by word, write our equation, find our K. So start with G varies. So G equals, always have a K. There's always a K there. Jointly. So which operation? Multiplication. So as W in the cube of X. So W, and then how am I going to write the cube of X? X to the third power. And then there's our curveball, and inversely. What does inversely mean? So I'm going to take, if you come to an inversely, it's the whole thing divided. Inversely means divide. As the square root of D. That's the square of. Square root. Yeah, the square root, the little Little shelter for the D. Square root of D. I won't give you one that's this involved, but that puts together everything. It's got our multiplication, it's got our cube, it's got our square root. So how many different things am I going to need to know in order to solve for K? 4. You're going to need to know the W, the X. What else, Brittany? The D and the G. You need to know everything but the K. But luckily we've got that. Again, the problem has to give you that. There's no way you could do this problem if the problem doesn't give you that. So there's our complete set. It's a big set this time. Let's put all of our numbers in. So 108 is equal to K, we never know at this point, times 9 times 2 to the third over the square root of 36. So let's go through and clean this up a little bit before we try to get the K by itself. So I'm going to go 108 is equal to K times 9. I'm going to 2 to the third is 8. And then the square root of 36, 6. So I'm looking at 108 is equal to K times 72 over 6. Now there are a couple different ways you could finish solving this. Just to be consistent, when we had a denominator of 6, how did we get rid of the denominator? Multiply both sides by 6. So if you have one of your numbers in the denominator, just multiply both sides by that number, and then you can get rid of the fraction. That actually goes all the way back to unit 2. So that's kind of a consistent method to get rid of your fraction. So I have 648 is equal to K times 72. And then what's my last step to solve for K? Divide. Divide both sides by 72. And after all that work, K equals 9. Again, I'm not going to give you something this in-depth like on your test, but it exists. It's a good problem. It's got everything. K goes all the way back in place of the original K. So I have G equals 9 times W times X to the third all over the square root of D. And now we're able to answer our question. So we want to find, it says Y, that's a typo, that should say G. Now here's another thing. You might not just have to plug in and get the answer. I could technically give you G and say leave off W and have you solve around that. I don't think it ever does in this class, but it's a possibility. So we want to find G when W equals 5, X equals 3, and D equals 25. So we're just going to substitute in our numbers. So 9 times 5 times 3 cubed. Don't forget the cubed on your X value, and don't forget the square root around the D. And again, it's just a matter of simplifying. You could really put that in your calculator all at once. I might recommend numerator and denominator separately. Let's go 9 times 5 is 45, times 3 cubed, which is 27, divided by the square root of 25, which is 5. I'm just going a little bit at a time, simplifying. 45 times 27, 1215 over 5. Oops, I did. What did you have? 243? Yep. Where's my G? So G equals, I agree with that, 243. And again, you could do that in fewer steps, certainly. Once you've got your numbers, you could even do it all at once in your calculator if you use enough parentheses. But that is at the top of how bad the problems could probably look. I don't even know if your homework problems, there's got to be something else. There's got to be a reason I included one like this. So you can have a lot of stuff happening in one problem. But the process, exactly the same. Write your equation, find your K, finish the problem by answering the question. Questions? Now, they're not always just straightforward, this variable varies with this variable. There's also some word problems that look like they're going to be worse than the ones we just had. They're exactly the same. You've just got to ignore the words we don't want. So like when you come to your test, you start reading this question. So distance the spring will stretch varies. I see the word varies. As soon as I see the word varies, directly inversely is in there, so it varies directly. I know this is one of my variation problems. I know this is from 7.8. It's the last thing we did in this class. So let's start reading it piece by piece. So the distance a spring will stretch. That's what's varying. I suggest you choose a meaningful variable. So what variable might we use for the distance a spring will stretch? D. I would absolutely pick D for distance. So that whole bunch of words, we're just going to reduce it down to D. And then we've got our word varies equals K. Directly times, and as the force applied to the spring. So we need another variable for the force applied to the spring. F. That's a perfect variable. And the reason I choose them meaningful is it's a little bit easier when you go to substitute to make sure you get the numbers in the right place. So a force of 6 pounds, okay, a force of 6 pounds is required to stretch the spring 4 inches. So it's not, again, quite as clear cut. We have to figure out which one's the distance and which one's the force to get the numbers in the right place. So is the 6 going in for D, or is the 6 going to go in for F? F. The force of 6 pounds. And that's why I would choose those meaningful variables, so you get your numbers in the right place. So F is 6. We'll stretch the spring 4 inches. And that makes sense. 4 inches is a distance. So 4 is going to go in for our distance. And now we've got to solve for K. I'm going to solve by dividing both sides by 6. So I get K equals 4, 6. Now every other time we could divide, and we just got this nice even number. 4, 6 is not an even number. And I don't want any rounding errors, so we're not going to round it. We're going to leave K as a fraction. I'm not going to leave 4, 6. But we're big kids. What can we write in place of 4, 6? 2/3. So we're just going to say 2/3 equals K. If it divides out evenly, by all means, use that decimal. But 2/3 is a non-terminating decimal, so I'm going to keep it as 2/3. So distance equals 2/3 times force. Now let's read the question. What force is required to stretch the spring 24 inches? Which variable do we have? Do we have a distance or do we have a force? What's the question? What force? Do we know the force? No. It's a distance. 24 inches. 24 inches is a distance. Remember, I said it's not always the stuff on the right. You've got to look at what you have. 24 inches is a distance. We said 4 inches was a distance. Force is measured in pounds. So in place of D this time, it's not always just throw it in on the right. In place of D, we have 24 equals 2/3 times F. Now, there are like 3 different ways you could go about solving this. If we're going to be consistent, if I have a denominator, how can I get rid of a fraction? Multiply by the denominator. So if I want to get rid of the fraction, now you could say, okay, I'm just going to divide both sides by 2/3. That works. But if you want to clear the fraction, multiply by the denominator. So if I go through and I multiply this by 3, just to cross out the 3, multiply the other side by 3. It's the fastest way to get rid of your fractions. If you see those fractions, you don't like them, just multiply by the denominator. Get rid of it. So I have 72 equals 2 times f, and now my last step to solve for f is to just divide by 2. So I get f equals 36. And force, I don't take off on you guys, but it's always good to put some labels. Forces in pounds. So with the full word problems, you have to read a little bit more carefully. You have to sort your information, but the process is exactly the same. Questions? Again, other ways you could have solved this, you could have just multiplied by 3 halves, or you could have divided by 2/3, which multiplies by 3 halves. And this last one is actually directly from your homework, just with some different numbers. You have this image in your book of a bike that's turning. So the figure shows a bicyclist tips its bike when making a turn. That's wonderful. It doesn't help us with this problem. The angle B formed by the vertical direction of the bicycle is called the banking angle. Okay, it just gives us some information. The banking angle varies. That's where I really start my problem. So I'm going to start here because I found my word varies. Because when I'm reading my test, if I'm reading my final, we have a bunch of different types of word problems in here. But when I see that word varies, that's how I know it's from 7.8. So the banking angle varies. What variable do we want to use for a banking angle? B. And the problem did say to use B. I'm not picky about that. I'm not going to give you that variable. So B, and then what goes in for varies? Equals K. Inversely was which operation? Division. As the cycle's turning radius. So we need a variable for the cycle's turning radius. R. I would choose R for radius. That's the most mathy word in that sentence is the radius. So we'll put R in there for radius. When the radius is 2 feet, the banking angle is 56 degrees. So now we've got to make the decision of which place those numbers go in. So the 2 is going in for B or for R? R. It's a radius. That's why we choose those meaningful variables. So I'm going to put 2 in for R. And then the banking angle is 56. And we chose the banking angle to be B. We put 56 in for B. How do I solve this one for K? Multiply both sides by 2. Number in the denominator, multiply both sides to get rid of it. So we know our constant of variation, K, equals 112. And we can take that K, put it back into our original equation. Now so we've got our setup, we've got our K solved for, now we answer the question. What is the banking angle when the turning radius is 3 feet? So do I have the number now to go in for B or to go in for R? R. These are the questions that you should be asking yourself as you're working through these. So I've got B equals 112 divided by 3. That's our new radius. Which is, it's really 112. It doesn't actually reduce. If you were going to write it as a mixed number, it'd be 37 1/3. I would take 112 over 3. I'll take it as the 112 over 3. Really, you would put this to a mixed number. But if I told you your bike's going 112 over 3 degrees, probably doesn't, can't really get a visual of that. 37 1/3. I can get a little bit better visual of that, but I would accept either of those since the fraction can't be reduced. questions? All right, so I need you to get a partner